Emily, the bicycle essays I probably won't have done grading until at some point during a winter break. Start with 59. Problem set is 4, Richard. Okay, so I'm graphing the function 4 sine of 2x plus 4 minus 2. I've got amplitude shift, I've got a period shift, looks like I have a phase shift, and I have a vertical translation. And yes, the essays will make it into the semester grade, Colby. So I want some graph paper. So let's see, x-axis, y-axis. I'm going to scale 1, 2, 3, 4, 5, 6. Here's pi. 1, 2, 3, 4, 5, 6. 2 pi. 3 pi. Can we have notes for the final? Yeah. 1 page, front and back. Richard is correct. Okay, and it's y equals 4 sine of 2x plus 4 minus 2. Only handwritten. No, nothing printed, typed, anything like that. Yeah, can't have it photocopied of someone else's handwriting. Must be handwritten by you on the page. Cool. Okay, so let's see. What do each of these pieces do? Well, I know that the 4 dilated the amplitude. I know that this changed the period, dilated the period. I know that this moves me left 2, and this moves me down 2. Yep, final will mainly focus on the second quarter. It's only second quarter, yeah. Okay, so I want to know what's 2 spaces in terms of my scale. So my scale, I have 6 spaces is equal to pi. So how many spaces is equal to 2? So 12 equals x times pi, and x is going to be 12 over pi. So 12 divided by pi, 3.8 spaces. So x is approximately 3.8 spaces. So when I say I want to move left 2 on my actual graph with my actual scale, I need to go left 3.8 spaces. So I'm going to move my graph left 1, 2, 3.8 and down 2. So how do I want to scale it? Yeah, scale. So here's 1, 2, 3, 4, -1, -2, -3, -4. Cool. So if I was graphing the original sine of x, this point would be at the origin, but I'm not. I'm graphing a transformed function, and now it's right here. And then I can go, let's see, I know my period is Richard, that's an excellent question. Why is it left 2, not left 4? Because you see this and you think to yourself, oh, I know this moves me left. Why is it not moving me left 4? That's a great question. If you want to, it's going to take us a little bit longer on this problem, but we can see it if we do each step. So why don't we try looking at it in Desmos before we do it here on paper by hand? So let's say I start with Ryan's got it. It is C over B. That's correct. Let's say I start with sine of x, and then I dilate the amplitude to 4 sine of x. And then I'm going to do my down 2, move to down 2. And, okay, Richard, here's the spot to watch. If I just had 4 sine of x plus 4, that would have moved me over left. Watch how this plus 4 moves me over left. Let's call this 4 number C. And watch how as I increase C, it moves me over left 4. So what happened there was that the value that used to be, let me add in here. Here's the old graph for sine of x minus 2. There's the old graph before I moved it. And this spot now became this spot right here. It moved left 4. So I'm going to highlight that spot, -4, -2. So far, so good, Richard? Cool, right? I made the amplitude bigger. I moved it down 2. Just like you said, it moved left 4. But now watch what happens when I change that to being, now I'm going to make it 2x plus 4, right? I'm going to make this b value, and that shrinks it back in. And it takes my leftward movement and it cuts it in half in this case. So it's b divided, or c divided by b, just like Ryan said. So now that point that wasn't -4, -2 is now only at 2, -2. So it did move left 4 in a way, just like you said, but then that leftward movement got shrunk towards the y-axis, and now it's only left 2. So you would divide 4 by 2 and you get left over 2 because of C over B. Correct. It is always C over B. As long as you have, Emily, great question. As long as you have y equals a sine of bx plus c plus d, then the phase shift, let's make it minus c. then the phase shift is always C over B. You actually had notes that said that. But that's okay. Why would you pay attention to the notes? How many problems were on that review list, says Nick? The problem set? Or the list we made together? Is that what are you asking about, Nick? The problem set. Hit a lot of problems. Should we count? Let's see. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 problems, Nick. Cool. So I'm going back to 59, just here. I'm actually going to graph it just so you guys can kind of see that dilation. I'm going to say, or sorry, the phase shift. So I'm going to graph first. Here in purple is going to be, this is 0, 0. I know the period got shrunk to 2 pi over 2 is just pi. So it's going to be all the way back here by pi. It's going to be here, halfway across, right up at 4 is going to be up here, and down at -6 is going to be down there. So there's the graph. This is y equals 4 sine of 2x minus 2. If I just had that, that would be 4 sine of 2x minus 2. But now we're going to say, okay, in black, here it is with my phase shift, which we already decided is going to move it 3.8 units to the left. So 3.8, right about there. And since I'm on an iPad, I can just kind of copy it and have a whole curve. Cool. Questions about number 59? No? Go on to the next one? Is that all? That was all. I did all those things. I made the amplitude 4. Amplitude here is up 4. Amplitude. And then I made the period be 2 pi over 2, which equals pi. So my period is pi. This is 1 period. Pi units. I moved the midline, so it was down 2. And I did the phase shift, which moved us, well, left 2 spaces. Is this part going to be on Desmos? Nick says, what was the original question for that problem? Graph the function, says Richard. I believe that's correct. Should we check what the instructions were? Let's see. It said graph each function. Each graph should contain at least 2 periods. Verify the graph and determine domain and range. So we've already checked it with Desmos, so we did that. And domain and range. Domain. X equals the set of values x such that x equals all real numbers. And range, the set of values y such that, let's see, I go from -6 is less than or equal to y, less than or equal to 2. Cool. So Elmer, you said, is that all? I guess now that's all that I've gotten domain and range, and I already had checked it on Desmos. Fair enough. Onwards. Onwards. Thank you, Brendan. Okay, 60. Should we do another one of these, or do you want to try something else? We are a tad behind, Nick. You are absolutely correct. I do not think I'm going to be able to do all 16 of these problems in the 2 hours. Uh-oh, and Colby's is lagging. That's bad. But I'll do another graph. And then you can say, hey, Mr. Williams, don't do another graphing problem. Do something else. Okay, 3 cosine of 4x plus 2 plus 1. So let's look at it. What do we know each of these things is going to do? Here, amplitude equals 3. Period is going to be 2 pi over 4, so pi over 2. Let's see. This is going to move us left 1/2, and this is going to move us up 1. Okay, so here's my graph paper. Nick, pretty much all the final is going to be about graphing and all that stuff. Like the entire thing almost. Maybe one problem that's not. Well, there's only 8 problems, so actually even more than 90%. Yeah, second semester is like all graphing too. That's bad, Nick. You should learn how to graph. It's kind of important to the whole pre-calculus class. Anyway, I'm going to start by graphing in orange. Let's see, my original function was 3 cosine of 4x plus 2 plus 1. I'm going to do it without the phase shift first, just like last time. 3 cosine of 4x plus 1. So in orange, I'm going to do 3 cosine of 4x plus 1. I'm going to scale to give 3, 4, 5, 6. And I'm going to make that pi over 2. So here's pi. Negative pi over 2. And negative pi. And I'm going to start up 1, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3. Here I am at 1. And the function has a period of pi over 2. So I know it's going to be back here. I know it's going to be there halfway in between. I know it goes up 3 to right there. I know it goes down 3 to right there. So we can pretty much say, okay, well, that was ugly. That's pretty nice. Alrighty, but I don't want 3 cosine of 4x plus 1. What I really want in the end is 3 cosine of 4x plus 2 plus 1. That's what I'm after. There are 4 non-Desmos and 4 Desmos, Nick. So I know that the plus 2 is going to move me left 1/2 in this case. 2 divided by 4 is 1/2. I need to know how much is 1/2 on my scale. So I'm just going to do a little proportional reasoning. I'm going to say I made pi be 12 spaces. So how many spaces should 1/2 be? So 1/2 times 12 is 6 equals pi times x. X equals 6 over pi. And let's find out what 6 over pi is. 1.9 spaces. So when I go back here, I know I'm going to move this black function almost 2 spaces to the left. And there it is. Are we going to have to write on any of them, Colby? Yes. You're going to have to write. And they asked me to find domain and range and verify on a graphing utility. So I can see domain, the set of values x, such that x equals all real numbers. And I know range. It goes from -2 up to 4. I don't know who Bizrat Sultan is, but why is it 1/2 to the left? It's 1/2 to the left, as we explained about the last time, that it was B over C. So it's this value 2 to the left divided by the period dilation. Yeah, C over B, just like Shemaiah said. So it's this C value of 2 divided by 4. Because the 2 moves me 2 to the left, but then the 4 moves me, thank you, Richard, C over B. 2 divided by 4 is 1/2. The 2 moves me to the left, and then the 4 shrinks it back towards the y-axis by a factor of 4. If we want to check in Desmos, which we were supposed to do for the problem anyway, we can kind of watch that happening graphically. So we can say, here was the original function, 3 cosine of 4x plus 1. So there it is before it's been dilated. Oh, let's check out 3 cosine of just x plus 1. And then if I did my plus 2, that moves it to the left. Let's watch it move to the left. So here's C plus C. And we can watch, here's C at 0, and it moves to the left such that the point that was in the background, 3 cosine x plus 1. So that point moved left 2. So here's the green point, 0, 4. And it moved to the red point, -2, 4. There it is. And so I moved it left 2 with this C value becoming 2. But then what happens, and this is why it's C over B, is we get 3 cosine. The next function becomes 3 cosine of 4x plus C. And that takes that leftward translation of 2 and divides it by 4. So now it's only 1/2. Yes, Richard, if C is positive, it goes left. If C is negative, it would go right. Nick says, have these past 2 problems been ones we can or cannot use Desmos? You should be able to graph a sine or cosine function without the phase shift, without Desmos. I would say if there's a phase shift, especially one of these phase shifts where it's a shift in units, where like the period dilation keeps it in pi, but then it moves over 2, which is out of pi, that's a time for using Desmos, where you're getting like all of your values become off. That's a nice time to use Desmos. But if all the values are nice, then you should be able to graph sine or cosine without Desmos. If it's secant or cotangent or something, that's a good time for Desmos. You don't need to be able to graph secant or cotangent without Desmos. Did I answer your question, Nick? So these two, both of these had these kind of awful phase shifts, Nick. So those would be Desmos questions. A secant graph or a cotangent graph, that would be a Desmos question. Cool. I'm hearing a lot of problems about lagging. Do you want me to turn off the live stream and try it again with like lower video quality or something to see if it goes faster, or change the buffering settings? Yeah, Shania. The questions that we had on our last quiz, I think they ended up in the Desmos section. Yes, I'm pretty sure. Should I try it? I'm gonna have to turn it off. Is that okay with everybody? The unit circle is up all over my classroom, right, Oscar? If I actually just asked you to write the unit circle again, you can probably just look at the wall if you still haven't memorized it. Okay, but I'm going to leave you all, and I'm going to try to change the video settings. So I'll be back in a bit.